Okay, at the end of the last video, we concluded with the following two polynomials being given, and we were going to show that if we do the division by division, the remainder will be 0, and hence x minus 1 is a factor of p of x, and p of 1 is 0. So let's go ahead and do the division. X cubed minus x squared plus 4x minus 4, and divided by x minus 1. Well, dividing lead terms, we get x squared here, so x cubed minus x squared gives us 0. So we drop down the last two terms here, 4x minus 4, and so we get plus 4 when dividing this lead term by this lead term. Multiply that, we get 4x minus 4 here as well, which when we subtract, we get 0. And so we can write x cubed minus x squared plus 4x minus 4 as the quantity x minus 1, the divisor, times x squared plus 4. And hence, we have that this polynomial p of x is actually, well, plus 0, the remainder, but we have actually that this is the case, so hence x minus 1 is a factor of p of x, and p of 1, which is 1 minus 1 times 1 squared plus 4, that's 0. 0 times 5 is 0. So that's what we get. Okay. What I'm going to do last here is, this is the last part of this section. This is kind of a short way to do long division, but it only works for these special cases. And it's called synthetic division. So given this only works given any p of x, and d of x must be in the form x minus c for some number c. So we cannot, so let me just write a couple of examples of when you can't do it, can and can't do this method. So just a couple of examples here. So example 1, p of x is, say, x to the 4th minus 5x squared plus 2, and q of x is 2x plus 1, then we must do long division. We must do, sorry, not q of x here, this is d of x. Must do long division if we want to divide p of x by d of x. If you have the same p of x as 1, and d of x is, say, x squared plus 5, again, you must do long division. But if, say, example 3 here, we have the same p of x, but d of x is, let's just say, x plus 5, well, this is x minus 5, where c is minus 5. In this, we can do this process called synthetic division. Okay, I'm just giving some examples of when you can and can't do synthetic division. Now we'll do this example in a moment, but let's start with the one that we already did. Let's start with the one which was x cubed minus x squared plus 4x minus 4. Let's say this was p of x just like before, and d of x was x minus 1. How would you do this using synthetic division? So what your steps are as follows. So first you want to write down, so step 1, write down what c is, as well as all the coefficients of p of x. So in this case, in our case, c is 1. And the coefficients, I'm going to write it this way. A sub 3 is 1. A sub 2, the coefficient x squared is minus 1. A sub 1, the coefficient of x is 4. A sub 0, which is the constant, is minus 4. And what we do is we draw a little box like so. And A3 we put here, A1 I put here, sorry, A2, and then all the coefficients in a row, I'll just put them one next to each other. And this C value, the C I put right here. So let's put, say, 1 here. This is 1. Now, what do I do? This is a procedure which you'll see it works out. Rather than doing all the explanation of why, let's just do the method. So what we do now is we drop down this 1. Okay, this 1 drops down. And then what we do is we multiply this 1 by this 1, and then we place it here. So that becomes another 1 here. Here now, we add. Here we add. Negative 1 plus 1 is 0. And that's when we add negative 1 plus 1. And then we again multiply this 1 by this number, which is 0. And we place that over here. So we place the number 0 here, because 1 times 0 is 0. We add now, whoops, put that in red. We add 4 plus 0 to get 4. And then we multiply 1 times 4. What do we get when we multiply 1 times 4? We get 4. And what we end up with now, when we add negative 4 plus 4, gives us 0 here. So what is this? What are these numbers actually saying? These numbers right here, these corresponds to the coefficients. These are the coefficients of q of x, the quotient. And this number, the last number, is the remainder r. So r is 0. And remember, this 1 corresponded to x cubed. This negative 1 corresponded to x squared. This was the x term, and this was the constant term. Well, the numbers below correspond to degrees 1 less than the one above it. So for example, in this case, the 1 corresponds to x squared. The 0 corresponds to the x term. The 4 is the constant term of the polynomial q of x. Of the polynomial q of x. So we have then that q of x is equal to 1x squared plus 0x plus 4, which is x squared plus 4, where the remainder is 0. And our d of x was given originally as x minus 1. Q of x, oops, not q of x, p of x was x cubed minus x squared plus 4x minus 4. And notice this exactly corresponds to what we had above. X cubed minus x squared plus 4x minus 4 is equal to x minus 1 times x squared plus 4 plus the remainder 0. Okay. So this is an example of synthetic division right here. Let's do this process for the example that we had above, where p of x here was x to the 4th minus 5x squared plus 2, and d of x is x plus 5. So let's do that. X to the 4th minus 5x squared plus 2. This is p of x now. We're starting a new problem. Let's just draw a giant line here to separate. And let me go back to white. D of x here is x plus 5. So what is our steps again? So step 1, identify c as well as the coefficients of p of x. And now here it's just slightly different. Notice this p of x, this is x to the fourth plus 0x cubed, because there's no x cubed term, minus 5x squared plus 0x plus 2. So we always have to write every single coefficient down, even if they're missing, because that's kind of how the process works. So a sub 4, for example, is 1. A sub 3 is 0. A sub 2 is minus 5. A sub 1 is 0. And a sub 0 is 2. And c here, since this is x minus minus 5, c is minus 5. So we have minus 5 on the outside, and we draw a kind of large L-shaped part of a box. And then we put down these coefficients, 1, 0, negative 5, 0, and 2. And we start off by dropping down the lead coefficient of p of x. So we drop down this 1, and then we multiply negative 5 times 1, which is negative 5. Oops, let me write that in white. So we have negative 5 here. And now we add here. We add these two to get negative 5. And then again, we multiply negative 5 times negative 5, which is positive 25. And we put that positive 25 here. So we put a positive 25. 25 minus 5 is 20. And then we multiply the negative 5 times the 20 to get negative 100. And once we do that, then we add 0 plus negative 100 to get negative 100 here. Multiply by negative 5, we get 500 here. We add again to get 502 as our remainder. Okay? So what is this saying? This is saying if p of x is x to the fifth, remember this was, x to the fourth, this was a fourth power of x, this was a third power, this was our x squared term, this was x, and this was the constant term, then these guys below, are degree 1 less. So this is the x cubed term, this is the x squared term, this is the x term, and this is the constant term. All of this is going to comprise of my quotient q of x. So what is, if p of x is x to the fourth, minus 5x squared plus 2, then, and d of x is x plus 5, then q of x is going to be the quotient. When you divide p of x by d of x, this is going to be 1x cubed minus 5x squared plus 20x minus 100. And our remainder here is going to be 502. So x to the fourth minus 5x squared plus 2 is equal to x plus 5 times x cubed minus 5x squared plus 20x minus 100 plus the remainder 502. Okay. So this is the general procedure. You can check if you'd like and multiply this out, but this will work out. We'll leave you here with a little exercise. By the way, this also tells you that p of negative 5 is 502 from that theorem 1 that we stated, I think, in the previous video. P of C is equal to the remainder R. That's what we saw. And C here was -5, and R was 502. Okay, I'll leave you here with an exercise in synthetic division. So divide P of x, which is, say, 2x cubed plus 4x minus 1 by d of x, which is x minus 3, using synthetic division. Okay, we'll end there, and we will start the next video with this exercise. And maybe what I'll do is find P of 3 using the result here. Okay, we will continue into 3.4 starting the next video.